All right, hello everyone. Instead of writing the feedback, I thought that I would practice for my future career as a vlogger. So I'm gonna record a video faster for me and also maybe a bit more interesting for you to listen to than to read the feedback. So I'm gonna go over how I mark the assignment. I will send you all a breakdown of why you got a mark, and if you have questions, just get back to me. But first, watch the whole video to see how I mark, so that because the comments can be a bit short, but then you can understand why you lost some marks. So first, I mark with the grading scheme that I had given you in the assignment. I will send you a file. This is the file like that one here, markdown file, where I put some grades for all of these parts. So what I did basically is I read all the reports and then I marked them. This is pretty subjective, I have to say. So marks go from 1.5 out of 3 to 3 out of 3, I think, one group, or 2.75. I'm not sure. And I think I put 2.75 as a maximum. You all had pretty good report. When I read a report, maybe I've said it before, but you don't really need to repeat everything that I've told you. So if I told you to take the file and remove all the parts that are not necessary from the file, you don't need to spend half a page repeating my words. I know that you're doing that. That was part of the assignment task to do. So just focus on what you have done and explain me how you've done something. So many of you lost marks because you basically sometimes just said, I calculated the area, and then you didn't really describe me how you calculated the area, but the method to calculate the area wasn't prescribed. So I really wanted for you to explain to me how you did this. And there were many ways to do it. I'm going to discuss it in a minute, but if you didn't explain to me how to do this, then you lost some marks. Also, not many, but some of you omitted to have the discussion that I asked. So if the data is not of good quality, if there's a hole in your volume, if there's duplicated points, can you still calculate these attributes, and how do the errors influence the results? So there's a lot of answers, but if you made an effort to discuss what were the consequences, then you got your marks. Most of the time, if you didn't, then you lost some marks. So there were 3 points for this. Then I checked if the file is valid. And by this, I meant that I basically check with CJVal, so the syntax of the file. So if you go to validator, so I had a question, I'm just maybe repeating it, but I basically check if you went there to validator, the ctjson.org, if the file was valid. So was the file valid, syntactically valid according to the schema? Was it a ctjson? Was it a JSON file? Was it a ctjson file? And also I checked if you put the new attributes where they should be and in the ways that I wanted you to put the attributes for the surfaces, but also for every building. So if you did all that, then you got 1 point. If you messed up something, you lost automatically half a point. Then I ask you to write a README and if the code is clear. So I wasn't really, you didn't lose mark if your code was a bit messy. Some of you had extremely good code. I wrote it in the comments. Some of you had more messy codes. You're still learning to program, so that's not really, you're not losing marks, but I will give you a bit of feedback in 5 minutes about what you could do to structure your code better. Some of you just had like 4 functions where you had like a 200-line function. This is not really good for you, more than for me. It's easier to debug and to find errors and to understand your own code. And if you open the same code in 6 months, you will find it really messy. So it's good to always, when you code, try to be structured. So you don't lose mark, but basically, if you had a README, if you give me the code, then you got all your points there, 100%. And then I think most people got it, unless you didn't submit the README or you didn't submit the code. And then there were the 4 attributes that I'm going to discuss in a minute. So how I marked is, well, I check the file, I check the report, and then I focus basically on 3 buildings for which I have calculated all these attributes, and then I check them manually. So if you got these wrong, then you lose your points. I didn't want to mark every building for everything. I just focused on two so that I can understand what are the errors. Basically, I picked two. So one that I call the building B1, which is one in the file that you had. I calculated its volume, and then I checked one orientation was northwest and the other one was southeast. Then I took the old building inside, the old building where I was working. It's called the OTB building. This is close to Beka City. So it's this building here. It looks like that from outside. This is where the international school is. So this is the OTB building. So I also calculated everything there, especially I used that one because one of the surface, the top surface, had 5 holes, as you can see here. I think they're already there. So this one was good for me to see if when you calculate the area of a surface, you also remove the 5 holes, and the value that you were supposed to get was this value, I think. So then I went in your file and I checked that if you had that value or not, and also if this one was pointing upward, so the value that you got for the orientation should have been written horizontal and not one of the values that you get. I also so basically I mark with that file there, so you can see here. So these are the details of what you should have gotten for the values. Oh yeah, by the way, a lot of you discuss about the precision or the accuracy. A lot of, well, some of you didn't get, let's say, 23.96, you got 23.82. A lot of you try to dig about why this is happening. I'm not sure, I'm going to discuss in a minute, but I wasn't really difficult for that. So if you got 23.5 or 6 or 24.0, you got full marks. Same thing for the volume. So I did it for the 2 buildings, B1 and OTB. And then I also took one building, which is building, I call it the building 302. This is one building with the ID here. And this one had the shell not closed. And then I checked this one, what did you do for the volume of that one? So if we go to this, so the building was basically that one. So if I open it into MeshLab, it was that building here, just one building, that looks completely valid, but in Val3DT it was giving an error 302, and 302 is shell not closed. It means that there's a hole somewhere. So basically what I did is I checked how you handle that one, and many of you lost 0.5 points there because you gave me a volume. So if in the report you wrote that you were aware that the value that you were giving me was wrong and you couldn't rely on it, then you lost 0.25 points. But the right answer was, I don't know what is the volume of that one because this is not a closed shell. And even if you go to, if you load that one, so basically I took the building, I exported it to OBJ with CGIO, and then if you go and then you check for the geometric measures, compute geometric measure, if you call it, you can see here in the mesh is not watertight, no information on volume, barycentric center, and inertia tensor. So MeshLab tells you that it's not a closed mesh, there's a hole in it, so I cannot calculate the volume. And it makes sense also, because if you think of it, if you have a cube and then so now the crack is very small. Sorry. So the crack here is very small. If you want to check the crack, you could either run Val3DT, which it would tell you the location of the hole and then you can zoom in. But you can also go to MeshLab, load it, and then do selection, select border. Border means basically faces that have a border, which an edge that there's no 2 faces that are incident. So basically, if you select this, you see here that it gives you 5 faces and they're selected. And then if you go and then you try to find them, yeah, they're here in red because they were here. So they're very small, but it's still a hole. And it means that you cannot reliably calculate the volume. The thing is that if you say, well, my code calculated a volume anyway, it didn't crash. I know it didn't crash, but here the volume that you obtain is probably very close to the real one, but not necessarily, because maybe there's a hole or there's something intersecting and the orientation is reversed. I don't know. And the way that you calculated maybe can be very far away from the real answer. And if I had, for example, let's say you have a cube, but then you remove the top face, which is a massive face of like the previous building of 700 square meters. If you remove that face, so just take one of the buildings that you had that was valid, remove one face, and then calculate the volume with your code, you will see that the volume will not crash, because the algorithm that you needed to use will simply take all the triangles, create tetra, iterate over them, and return a value. It cannot really crash because you simply calculate the determinant. Even if you have a flat tetrahedra, so a tetrahedra whose 4 points are lying on a plane, it will return 0, or very close to 0 if you calculate the determinant of the matrix. But it will still give you an answer and it will not crash. But the fact that it doesn't crash doesn't mean that you end up with a reliable volume. The only way to end up with a volume that you know it's the volume is if you have a shell that is perfectly close. If there's duplicate vertices, then you can probably recover from it. A lot of you told me. So duplicate vertices would create a flat or a collapsed tetrahedra that will give you 0. You can recover from that, no problem. But if there's one error that you cannot recover from is error 302 in validity, or if you have holes in your shell, and if you have holes in your shell, then you should do what MeshLab is telling you. I cannot reliably calculate the volume, therefore I'm not calculating it. And you should probably do that, because if in 2 years you work for the government, in this country we pay taxes based on the volume of our buildings, for example. In many places they do that. So then if you just calculate the volume of a building and you make an error and it's way bigger, then the person will pay way more taxes. Maybe your boss will be happy, but the people will be less happy. So it's better to say, for that one, I don't know, you flag it, then you go, you repair the geometry somehow manually or automatically. There's methods to do it. You can try here with MeshLab. You can, for example, do remeshing. You could see we didn't do that in the course. Maybe we should add it to the course. But there's ways to remesh, to fill holes in the mesh, and you should do that until you get a valid mesh, and you can calculate its volume, and then you could add it to the file. But for the assignment, the right answer was volume for that one was null. I don't know. Okay, let me continue. So I use these 3 files. Okay, let me go quickly. I'm not that quick. The first one is number of floors. So when I wrote the assignment, my first idea was that you really take all the roof surfaces and the wall surfaces, and then you iterate over them, and then you try to find the average of the eave and then the top of the roof. That was my idea. But I had forgotten that there was an attribute, the height of the roof max and min. And some of you used it, and Ravi, even in the lab, gave you the green light to use it. So basically, all of you, except I think there was 10 submissions, 8 of the 10 submissions did that, and 2 submissions did what I had in mind originally. I think what I had in mind originally is probably giving better answers. Some of you did a nice analysis in that. But since Ravi allowed it, and since I didn't disallow it, then most of you got the right amount, the correct amount of floors, which was very easy. It was a simple finding these 2 values for every building. If they're not, so some of them didn't have anything because they didn't have any points inside. You just needed to handle that case, but you would notice, otherwise it would crash. And then you just needed to output the value, which most of you did. One warning, this is where a few teams lost points there. So some teams wrote it this way, and then if you do that, you lost 0.5 points. That's a bit harsh, but there's a reason, is that in the description of the lab, in the description of the assignment, which is here, I had explicitly said I want these, and I want you to write NO_ floor, and then I want you to store it as an integer and not as a string. So if you check here, what these people wrote, and this is a real submission, it's floor, and then 2 is as a string and not as an integer. You might say, yeah, but you could find it. Yeah, I could find it, but that's why I didn't do it on... If I had done automatic marking where I parse all your buildings and I check what is NO floors and I compare it, a lot of you would have gotten 0 because you didn't store what I wanted you to store. And computers are rootless, while me, I can say, oh, where is number of floors? Not there. Then I find that there's someone wrote floor, okay, between a string, then I need my head will convert the string directly to an integer. But for a computer, these things are difficult. So be careful about what we prescribe in an assignment, but it's the same as if you have a job later. If the attribute should be called NO underscore floor, if you don't put the underscore, then you will get problem because a lot of application in downstream application will basically use your file to extract things. Then we say, well, number of floor is not there, I cannot find it. So this is very important that you follow the what is prescribed for the attributes. So most of you got it right, except a few things. Yeah, so that I've just explained it basically. So for the file, for one file, you needed to put null because it wasn't always possible, that I've said it. Volume with consecutive duplicates, I also said it. So basically, if you have, let's say you have a triangle. Let's say you have a triangle and then you want to create a tetra. So you give your 0 here. You create that tetra, you will find its volume. So you will get a volume of, I don't know, 337 cubic meters. But if somewhere you have another triangle, which is, let's say here would be 0, 1, 2. And here, let's say you have 0, 1, they're the same location, and 2. And if you get a point here, you will create what I called a flattened tetra. And if you create a flattened tetra, then it's going to give you 0. And most likely, unless there's something else happening and the topology is not good, but if your shell is closed and you only have duplicate vertices, then you will recover from this because that will give you a volume of 0, and then that will not influence everything. Sometimes you can have cascading effect, but let's say duplicate is pretty easy to handle. You could just ignore it or just process it, depends on how you write your code. Some teams to verify their code use MeshLab. Some of them use Blender. So there's a Blender plugin where you can load CityJSON models into Blender. It was incidentally written by a student, MSc student, that did it during his MSc thesis here at TU Delft. He wrote the plugin. Some people use it and then they use the plugin. They use the tool. I forgot what's the name of the tool. I can tell you. I asked the student to use it in Blender to calculate the volume. But just to show you that the volume is pretty complex to calculate. You did realize while you implemented it. But one student reported that he took, let's say, the triangulated file that I gave or that he obtained with CGIO. Then he loaded it into Blender, he calculated the volume, and he got, let's say, 1000 exactly. And then he took the same file, not triangulated, he loaded it in Blender, and he obtained a different value. And the correct value was the one with the triangulation, and the one without the triangulation wasn't valid. It wasn't the right volume. And then he asked me why. And then my answer is, well, the person who coded the volume didn't know what he or she was doing, and there's a bug in the code. Where is the bug? I have no idea. I guess it's open source. We could go check. But just to tell you that software is tricky to write. It could be that someone just decided to write it. They made a small mistake, never been identified. And now we realize because we use a triangulated one, and the triangulated one, the value that you get in Blender is the same as the one in MeshLab. But if you just use Blender blindly, with input that is not triangulated, then the volume that you get will be wrong. And that's just a kind of a warning that says, do not always trust blindly what software is telling you. Also, same thing, do not trust blindly what the internet is telling you. But this is like one example that I found was pretty funny and also a bit alarming. Hold on. What did I wanted to say? Oh no, it's here. Okay. Sorry, no, I'm just looking for a white page. So forget this. I'm not speaking about this, but just one thing about, or do I have accuracy? No. Okay, so I will speak about the accuracy of the volume here. Just one note. So some of you, oh wow, I'm writing over my face. So I just wrote accuracy of the volume here. Accuracy volume. Okay, so one thing about some people said I obtained 836.222, and then the answer of MeshLab is 836.888. Why is that? Is that an error? Who's right? And the answer to that is I don't know, but if you are really careful in implementing your algorithm, maybe you are more right than MeshLab. As I said, you shouldn't trust everything blindly. And I will just give you one example where I think that you could improve your accuracy. Is that since the file we gave you is in EPSG 7415, then we know that around Delft, so we were in Delft, the x coordinates are around 85,000 and the y coordinates are about 400,000, right? So what happens is that a computer have a fixed precision. So if you use double, then you have 64 bits or 32 bits. I don't know, it's a double 64 bits. But if you already use a lot of numbers, then you will have less space to store some after the dot. So if you translate everything to 85,000 and 500,000, then all these are taking space. While if you only have a building, you could actually, if you're interested in the volume of the building, you could just translate that building. So let's say you have a building. You could say my zero is here. And then instead of this one being 85 or 86,000 something, then this one would be 2. And then this one would be 3 meters because it's only a meter from the corner. So doing it per building is possible, but what you could have done is that in every file you have a translate. So if you look at the original file that I gave you, or let's say that one here, if you open it into Sublime Text, if you open it into Sublime Text, you will see here the transform. So the transform gives you the scale, basically how do you need to convert the integer to float. So this means that millimeter, but then the translate is basically, I think in this case is the minimum of the file. So minimum X, minimum Y, and Z, I think we put 0. But you see it's 85,000 and almost 500,000. So what you could do once you're converting so I gave you a function to convert the integers to float. So what you could have done to avoid all the problems, since you know that area, volume, orientation, nothing will be influenced by a translation. So what you could have done is not translate the data, every X, Y, Z, and then you would have gotten better XYZ, not better, but smaller XYZ, where you keep more values or you have more places after the dot, and that you could maybe minimize errors. And you can say, yeah, does it really matter? I don't know. You can make a test, but if you have a big building that you have, I don't know, 100 surfaces, and then you put a point and then you calculate for all of them, you calculate very big values because the determinant is taking all these values, and then you make a 4x4 matrix, and then all these things adds up. And then at the end, it could make a difference. And I think it does make a difference. Another thing that maybe some of you did, only one team reported this, is that you have your data set here. So you have a lot of buildings in Delft, but the zero of EPSG7415 is somewhere here. So the 000 is actually somewhere in France. It's not even in the Netherlands, it's somewhere, I think it's in France, I'm not sure, so if I say something stupid, correct me, but I think I've seen that years ago. The 000 is actually very far, so what you end up doing, so some of you, for calculating the volume, you needed to generate a new point, so what you did is that you took a 0 that was maybe close to the building, but some of you put 000. So what you do in that case is that you create very, very long, skinny tetra that are 85,000 or 500,000 long, so the edges are like super long, and then you create super skinny tetra, and then these tetra, if you calculate the volume, then they have massive coordinates, and then everything adds up, and then apparently some people went overflow, so it means that they were multiplying such big numbers that the computer said, I cannot store the result into a double, I'm not sure what happened. This can happen as well, so this is a super bad idea. What you should have done is not use a point that's here, but use a point that's very close to the building to minimize this. All right, I think I'm speaking enough. You get the idea. If not, we can speak later. Then I'm going to move to the orientation. Yeah, the orientation, most of you got it. Also, one team made a stupid mistake, I guess, but the idea was simply to take a surface, calculate the normal by doing the cross product of two vectors that you find on the plane. You could use a triangle, or you could find the original plane, doesn't really matter. Then you project it on the plane by just dropping the z value, and then on the plane you find what is the angle with respect to the azimuth. And then the only way to do it, I think someone asked me, the only way to do it is basically to do if else, so a switch case. If it's between 0 and 45, then it's northeast. If it's 45, and the only thing you need to think of is if the normal is pointing upwards, then it should be horizontal. But be careful when you do that. All of you got it. I think it was exactly this, but never compare directly to your normal to 0.00, because it's possible when you calculate something, it could have been like a tiny bit not horizontal. It could have been 0.0001, 0.00002, and then could have been 0.999999993. And then I think it's still vertical. It's not exactly that. So I wasn't really strict on that. I checked the code. Some of you did that, I think. Did that. And but it's something that you should always do. So if you compare values, it was also in the chat at the beginning of the course, someone asked a question. If you want to compare X, Y, Z, never compare directly values. It's in the Discord chat. I answered something when a question of Adele. You should always compare to having a tolerance. So you take the value and then you subtract it with another value, and then you take the absolute value so that you know that you're close to 0 or not. Never compare directly the value, always use a tolerance. So am I within, I don't know, in that case probably for the 3 component I would say am I within 0.001 of the value. If you are for the 3, then you can say yes, it's horizontal. If not, then it's not horizontal. The surface area then was probably the toughest to compute because I didn't prescribe the algorithm. A lot of you started to Google. I think most of you got it. Some teams got some buildings that were wrong. So the inner rings, some of you didn't think to handle them or an error. Some of you also had for the very simple building that had only 2 roofs. Some of you had one plane that was fine, and the other one you had 0.4 square meters, which was impossible because the value was 23. So you should go check your code why this happened. But this one was more difficult because I didn't prescribe it, and I wanted you to be able to Google or to realize how this is done. So many teams use different methods. So the first one was to use what you learn in geo1001, the Heron's formula. That generalizes to 3D. Someone asked a question, but she said, I read in the internet it doesn't work. But don't say I read in the internet it doesn't work, just try it. Just create a triangle which is horizontal, vertical, slanted, and then see does it work. The hint was that it's using distances, so it should work. So basically one technique was I'm going to use Heron's triangle to take Heron's formula to calculate the area of every triangle in 3D, super easy to calculate. The only trick was how will you bundle all the triangles together and sum them up? How will you find all the triangles that are part of one surface? Some of you, I guess you spoke to each other, or all of you just had a hallelujah moment. You find a pretty nice hack. The hack was based on CGIO. So basically, you modify the input file by adding one attribute to every semantic surface. Adding one attribute to an ID to every semantic surface in the input. So basically, if you had 6 faces, then you said ID1, ID2, ID3, ID4, and then after that you triangulate it yourself, and when you triangulate it keeps all these values so that you could keep track of everything. If you did that and you explained to me in the report that you did that, then great, you got all your points, and also if the formula ended up with the right value. Many of you did that. Some of you did that, but you never explained me that you did that. You just said I use Heron's formula to calculate and voila, it works. But Heron's formula is working for triangles, not for arbitrary polygons. So if you, that's an example where you lost point in the report if you didn't explain how you were doing that. So one other method that some of you found is the method here. That was the method 1. The method 2, project all on the same plane. So what you could have done is, since you have since you have a plane, you could just project everything on the plane, find the equation of the plane, convert it to a 2D case, and then use a 2D method that you use in geo1004 that you learned. You could have done that, but it's pretty complicated to project everything to a plane, find the equation of the plane. So that's where the method number 3 was probably the best for this assignment. So many of you found this on Stack Exchange. So Stack Exchange is your friends in Google. Basically, that was telling you how to calculate the area of a 2D polygon that's embedded in 3D, so that's planar. What you need to realize is that the method, some of you didn't seem to have realized that, I found that a bit worrying, is that this is basically the same as the decomposition method that I described in the assignment when I gave the description of the assignment, and it's also the same method that's been generalized to 3 dimensions. Basically, if you have a face like this, what they say is that you just need to find another point which is on the same plane. In that case, they find that one of the point is directly one of the point that exists in the polygon, so that makes a bit more simplification. And then you generate triangles the same way, and the whole formula basically gives you sine triangles, but you calculate the determinant of you calculate the cross product, the determinant you divide by 2. But that's exactly the same thing as what we're doing in 2D. We just assume that everything was on the plane. Now we just assume that everything is on the same plane. So if it's on the same plane, it works. But the idea is exactly the same. Taking one point, creating triangles that are signed because everything is ordered. And then if you go over your loop, then you calculate the cross product. The cross product gives you the area of the polygon spanned by these two. If you just want the triangle and you divide by 2, that's why you divide it by 2, but it's the same as the tetrahedra example that you divided by 6. So this method worked. Many people implemented it, so it was maybe a bit more difficult to implement, but then you didn't have to keep track of which triangle belongs to which face, and then you got your answer. Then some random tips. My God, I'm going a bit longer than I thought. Some random things. Some of you use Git. I think you should use Git. You learn how to use Git. And Git allows you to work in group, to have different branches for different people that use something. You can merge the code at the end. So Git is made for people to collaborate on projects. So for your future groups project, I would strongly encourage you to learn Git properly and use it, because you will save time in the end and you will avoid making mistakes. And if someone changes something and you say, why did you change something? You don't know. You will always know, because everything is in the commit. Some of you gave me doc files. I don't want doc files, so it's not that I'm difficult. I have Word in my computer, but it takes me like 15 seconds to load. And some people just wrote a doc file to tell me something that I use CGIO that just put it into a text file. And docs file are binary files, and they're well actually yeah, are they binary now? And actually they're XML file, but they're really complex files that doing the versioning of them in Git is not really possible. So if you change something in a doc file, Git will say, oh, the file changed. They will change the whole file. So usually we try to not commit to Git binary files. We try to keep to simple text files, so .md, .txt, so that we can keep track of something. It's fast, and if a line is changed, we can only change this single line has changed, so we can keep track. We can have a better versioning. Some of you use LaTeX. Great. I think you should all use LaTeX in preparation for your thesis. Never mandatory, but I think it makes better writing, better structure, less error, and so on. So once you have time, you should learn LaTeX. It takes 1 day, as I wrote. We have a small course, a small tutorial about what to do. Some of you used it, so great. Now I'll just show you some code. Just to give you, so yeah, I'm not judging your code, but I will give you a bit of feedback. What not to do, more or less. So here, if you look at this function, you can see that a lot of things are happening, but why I point this is that here, people say, I'm calculating the volume of a tetrahedron, but it's within a function. I think that you should try to not do that. Instead, you should create a new function that's basically double volume. You get something, and then here you call the function with the points. That's easier to debug. So if you want to know if suddenly you made an error in that function, it's easy to just call that function with only 4 points that are in a simple tetrahedron, and then you can see if there's an error. So be modular. Try to make, if you reuse something many times, try to always make a function. This is better to debug, to track errors, and also to reuse in the future. So I would strongly encourage you to not do this. Get volume function, and that volume function should probably call a function that gets the determinant, and then here you divide by 6. So actually that function should call another function volume that calls another function determinant, and here you divide by 6 and not necessarily there, because the determinant will be used for other purposes. So if you build a library, you will calculate a lot of determinants, so it's good to have one function that calculates determinant that you tested and removed all the bugs so that you can reuse it. I asked to give me a README. Some of them basically took the README I had, which just says how to compile, and that's it. This is not super useful, so I'm not sure if you lost points. I don't think so, but maybe one group will lost points. What I wanted is how can I run your code, and what data comes in, what data comes out. So if you say you compile it this way, okay, but what do I read? Do I read the original file? Do I read the triangulated file? Where will it write? How do I call it? This is all the things that I wanted to have. If there's a CMake, I know how to compile a CMake. It's still good to write it for people that don't know. But in this case, what I wanted you to tell me is something like this. So this person here, or this group here, their report contained the README, which was fine. I think it's better in a README file. But basically it tells me here how to compile. Here it says use an input file, use an output file. For example, this, then you can do that, and so on. And then all the files will describe what it's doing. So if I want you just need to write it, because also for you in 6 months, if you reopen your code, you will not remember these things. So be structured and always say how can someone else compile your code and how can they use it. Here, this is one, why did I put that here? Oh yeah, so now if we had a poll, I would say, what is the problem with that, these two functions here? So there's one function here, the function det for determinant, and then there's another function here. So there's a big problem with these two functions, and the problem is that everything is passed by value. So it means that here, if you pass it will always be only 4 by 4, I guess, the determinant, or 3 by 3. It will only be a vector of a vector. It will be 9 values, but the whole object will be copied because here you're passing by value. So everything by value. And we don't want to copy, we don't want to pass by value, we want to pass by references. So how to fix it? You add the ampersand here, ampersand here, ampersand here, ampersand here. So it means that the function that's calling that function will not copy all the value, but will simply pass the address of the original, the address of the original vector, and then we'll work directly on it. It's not even updating it in this case, it's just like basically reading the value. So there's no point in copying. A 9 value doesn't really make much problem, but again, if you have 100 of faces in a building and you have 500 buildings and you go on, this will add up. So I think if this person who did this, or this group, if you just added the ampersand, maybe the computation time would be, I don't know, improved by a certain percentage. And now it was small values, but if you have, let's say, all the points in a data set and you have 1,000,000, if you forget to put the ampersand, it means that all the time all the points are copied 1,000,000 times, then you can really improve your code by a factor 5,000 or a factor 1,000,000. So basically each time that you pass values that are not integers or double, simple value, each time that you pass a data structure, add the ampersand so that you pass by reference and not by value. This is the code of someone. Okay, didn't lose mark again. This was maybe too much of a hack for me. That was a good one. So this team, I really like what they did. This team, what they did is that they checked the buildings that were invalid in Validity. They copied the ID and then they hard-coded in the code all the ID. So basically it says that if you have one of these, then the volume should be null. Well, they put null between brackets which they shouldn't have done. It should be null. It should be null. I think you need to write none in C++, and none in C++ will translate to none in C++ will translate to null in JSON. But what they did here, yeah, it works. It's a hack, didn't lose point. But it's pretty ugly. So the right way to do this would have been to put all these 15 values in a separate text file that then you read, and then here, when you get here, you read the file, you check if they are the same, then you take a decision. But that allows you to basically deal with other data sets and not have problems like you will encounter now, because you might forget that you've put that there and so on. So it's way better to have an external auxiliary file that you read, that you can update, that you can maintain, and so on. So this is pretty ugly. I know it works, but just what you should do. Yeah, you should do that. Yeah, so this is, I've already said it directly, but this is the assignment of one team. Basically, if you see, they just use my main, which is file, and they have 4, I think maybe it's the same one. They have only 4 functions, which are like super long functions. They don't have functions for determinant. They don't have functions for calculating calculating the cross product, calculating, and so on. So they just have like super long functions, and there's not much reuse. So what should have been done is to have way more function, as I said, to reuse parts of the code. This is more what could be done also. So I understand why you put everything in the main. It's for simplicity, but if you write code, it's probably better to have a main and then have different units. So that person here, I think it's only one person indeed, he did it alone. That was nice code that says, so I have one unit that will calculate the surface area, another one, I'm not sure if I would have done that, but that allowed him to modularize his code so that he can later keep track of everything, fix bugs, and so on. And helper, by the way, was a different function. So the determinant, the volume, and so on, these were functions that are used by all of them. So he put all the code there so that he could also compare points and so on. All right, that was it. So that was short. 45 minutes, a bit longer than I thought. So I hope I didn't bore you too much. So check your file if you don't. If you have questions, let me know. All right.